One, let's discuss Amazon Virtual Private Cloud, or VPC as it's often referred to. This is one of the most fundamental aspects of networking on AWS. We're going to get into some of the details of this. Let's take a look at an overview of what the Amazon Virtual Private Cloud really is. It's a way of provisioning virtual networks that are hosted on the AWS Cloud and dedicated to your specific account. So these are logically isolated from other networks, and they work with other services like EC2. So some of the things that you can do with this is you can control IP address ranges, you can create private subnets, route tables, also network gateways and security settings. So they're really a way of completely controlling and virtualizing networking on AWS. And one of the things to consider as well is that it offers several layers of security control and also allows you the ability to allow and deny specific types of internet and also internal traffic. And it's also an inherently secure way to build your network. So what are some of the ways that you can integrate the VPC system into the rest of your services? Well, some of the things that work with the Amazon VPC system include some of the things we've discussed already, like Amazon EC2. Also, S3 works with VPC. This is actually a great way to test privately hosted websites. I've done this in organizations. Also, the EMR service, so Elastic MapReduce, Managed Spark and Hadoop. EFS works with the VPC system. Also, the rest of the database services as well. So there's a widespread integration of all these services. What about some features of VPC? Well, some of the features of the VPC system is that each VPC lives in a single region, but multiple VPCs can be associated per account. And you also can have subnets that divide those VPCs. And also you can create a VPC that spans multiple availability zones. So some of the ways that this works are that you can actually create a VPC that is fault tolerant as well as secure. Okay, let's talk about some of the other things as well that you may want to consider. VPCs, the addresses themselves, are ranges that can't be changed after you create the original VPC. That's one thing to be aware of. And also the addresses can't overlap in your connected network. So those are a few considerations to be aware of when you're creating VPCs. So let's now talk about some components. So some of the components of a VPC include subnets. So this is a way of segmenting the IP address range. And also you can classify these subnets as either public or private. So private subnets are actually a great way to have a very secure way of testing, let's say, a development environment. Route tables. These route tables can be used to control the traffic that goes into your system. And this is one way that you do this from a networking level. In terms of DHCP, this is a way of actually configuring which machines go into what part of your network. And then in terms of security groups, you also can have ability to restrict, let's say, port 22 or SSH access, or restrict maybe only exposing to the internet port 80. So you have granular control of which ports are open, both inbound and outbound. And then in terms of network access list, there's an optional layer where you can actually control at the network layer what actually comes across. Now let's also talk about some other optional components that may or may not come up with a VPC, and some of the ones that you will hear about are the internet gateway. This is allowing access to the internet from the VPC. There's also elastic IPs. So this does come up every once in a while. Maybe you want to associate an instance when it reboots to a specific elastic IP because maybe this is connected to your DNS server. So a lot of times you can have multiple different machines that use that same IP address. There's also elastic network interface, or ENI. So you may want to associate two different interfaces so that a machine can connect to two different networks. Also peering. This happens a lot with a more complex setup, like let's say you want to use a hosted Spark instance using Databricks, right, which is a popular SaaS-based Spark system, they would configure it for you and then set up VPC peering so that both of your VPCs could communicate. Now let's talk about some of the different kinds of connections that would occur inside of a VPC. So some of the connections that occur would be a hardware VPN. So this is a way where you can create IP security hardware VPN connections between a VPC and maybe a remote network. Another thing you can do is you can set up a direct connect. So this is basically a private connection between maybe your own private data center, and then you could hook that up to AWS. There's also VPN Cloud Hub. So you can create multiple AWS hardware VPN connections via your VPC to enable communication between different remote networks. And also there's software VPN. So one of the things you can do is you can create a EC2 instance with a VPC and the access, and then this one can actually use VPN software. Like one software package that I've used before is OpenVPN, and you can actually spin up an instance of that in the marketplace, and then you can use that to control access to your virtual private cloud. So let's talk about an example of a VPC application in action here. Really, let's break down each one of these pieces step by step here. So you have the region that you're in, and that's this outer layer here. And then you have the VPC itself, and inside this VPC, it actually spans the availability zone 1 and availability zone 2. And what this means in practice is that whatever you've decided to open up over here, maybe you've only decided to open up port SSH port 22, and you specifically allowed it to access maybe one host up here. That's the only thing that can come into that system. But maybe you also, because this is a web service, you could expose something like port 80. But really what this is a way of virtualizing and setting up a private network that you can control exactly what happens. So let's further break that down. And what you would typically do in a situation like this with security groups is you would define a very specific machine that you could connect to, or what you could do is you could actually set up a VPN system. So let's say inside of this network here, you could have a VPN server right here, and maybe this is running OpenVPN, and the only way that you can access all of these resources inside of here for development would be that you would have to, from the outside, maybe this client would talk to this VPN server, again running something like OpenVPN. And then once you have VPN'd in, then from there you can go ahead and SSH to machines and connect everything, because inside of here you have all of your security groups open so that different machines can talk to each other. So that's one security model. Another thing that people do as well is they may also create a host like an SSH host, and the only way you can come in is maybe you can open up port 22, and then you could tunnel back the traffic via port 22 and then talk to machines as well. So typically this is a very secure way to communicate with a VPC, and then you, using security groups, decide what ports you want to open. Typically it'd be like port 22 and maybe port 80 or port 443 for SSL. And so really those are the only things that are exposed to the outside world, and even you can map specifically the ports to specific applications. So you can have a very granular level of control when you use VPC. So let's go to the next section here and talk about CloudFront as well. So CloudFront is a way of having a content delivery network that has edge locations all over the world. And so it's built on the expanding global infrastructure, and it's also highly secure. And so it's a way of actually putting your data in a location that's closest to the client. So it's optimized for a few things here. It's optimized for low latency. So you can make sure that maybe your videos get directly to the client in another geographic region, and also for high transfer of the data. So the speed that you transfer the data. And it's cost effective because you only pay for that transfer of your data from, let's say, S3 to that CDN location once. And also it's deeply integrated with the rest of AWS services. So in a nutshell, global growing content delivery network. It has secure content at the edge location. It's also programmable. It's high performance. It's cost effective, and it's deeply integrated with other AWS services.